Hello everyone. Today we are going to learn properties of rational numbers. In previous video I had told you what is rational number. Rational numbers are numbers which are positive and negative fractions. Okay. So rational numbers are nothing but the fractions only, but they will have positive as well as negative numbers. Okay. So let's learn the properties of rational numbers. There are mainly 5 properties. Those are closure property, commutative property, associative property, identity property and distributive property. Actually, in some of my videos, I had told you these properties which are hold for whole numbers as well as for integers. So now today we will learn these properties for rational numbers. Okay, and here I am going to explain it with the help of examples also. So the first property is closure property. Closure property for addition says that for any two rational numbers, say a and b, if we add them, we will get the answer as rational number only. That means a plus b is also a rational number. Let's check it with the help of example. So here I am taking the value of a as 5 upon 3 and b as minus 4 upon 7. So when we add a plus b, here the a is 5 upon 3 and b is minus 4 upon 7. We have to check if I add them, then whether I am getting the answer as rational number or not. Okay. So now whenever we add the rational numbers, we have to use the rule of fraction only. Okay. Whenever we add fractions, what we do, we find the LCM of denominators. And if both the denominators are co-prime numbers, then directly we multiply them. So here 3 and 7 are co-prime numbers. So no need of finding LCM. So 3 7s are 21. And now I have to multiply the first numerator with the second denominator and the second numerator with the first denominator. So how, I'll tell you. We have to multiply this 5 with 7. So I got the answer as 35. 5 7s are 35. And now I have to multiply minus 4 with 3. So I got the answer as 12. 4 3s are 12 with negative sign because both of them have the different signs. Okay. Now 35 minus 12 gives us the answer as 23 upon 21. Okay, with positive sign because 35 is a greater number and which is having positive sign. Okay, so I got the answer as 23 upon 21, which is a rational number. So we can say that addition of rational numbers gives us rational number only. Therefore, rational numbers are closed under addition. Okay. Now let's check this property for subtraction. Closure under subtraction. For any two rational numbers a and b, if I subtract them, I should get the answer as rational number only. That means a minus b is also a rational number. Let's check it with the help of example. Here I am taking the value of a as minus 8 upon 5 and b as minus 3 upon 7. Now we have to subtract them. That means we have to find out a minus b. So minus 8 upon 5 minus of minus 3 upon 7. Okay. So as I told you, we have to use here the rule of fractions for subtraction. Okay. So here denominator is 5 and 7. So no need of finding the LCM. Directly we can multiply. So 5 and 7. 5 7s are 35. And now we have to multiply this minus 8 with 7, which give you the answer as 56. And in between we have negative sign. Then 5 3s are 15 with negative sign. Okay. Now here I got minus 56 minus of minus 15. Now whenever we have a minus sign before the second number in front of the bracket, then the sign of the bracket number will get changed. That means this minus 15 will become plus 15. So this number became minus 56 plus 15 upon 35. Now as both the numbers are having different signs, we have to subtract. 56 minus 15 is equal to minus 41 upon 35. Okay, and minus 41 upon 35 is a rational number. That's why we can say that subtraction of rational numbers gives us the rational number only. Therefore rational numbers are closed under subtraction. Okay, now let's check this property for multiplication. Closure under multiplication. For any two rational numbers a and b, a into b is also a rational number. Let's check it with the help of example. Here I am taking the value of a as minus 1 upon 5 and b as 9 upon 4. Now we have to check a into b. What we will get the answer. So here a is minus 1 upon 5 and b is 9 upon 4. Okay, as per the rule of fraction, we have to multiply numerator with numerator and denominator with denominator. That's why minus 1 9s are minus 9 and 5 4s are 20. So I got the answer as minus 9 upon 20, which is a rational number. Okay, that means multiplication of rational numbers gives us a rational number. Therefore, rational numbers are closed under multiplication. Okay. Now let's check this property for division. Closure under division. For any two rational numbers a and b, when we divide a by b, there is also a rational number. But closure under division for rational number does not hold. Why? Let's check it with the help of example. Here I am taking the value of a as minus 3 upon 4 and b as 8 upon 7. Okay. Now we have to find the value of a divided by b. So here the a is minus 3 upon 4 should get divided by 8 upon 7. Now, as per the rule of fraction, whenever we have to divide a one fraction by another, then we have to find the reciprocal of the second fraction and we have to change the sign by multiplication. The division sign will become multiplication sign. So here the minus 3 upon 4 will remain as it is. And then we have to write the multiplication sign and then we have to write the reciprocal of the second fraction, that is 8 upon 7 will become 7 upon 8. Now we have to follow the rule of multiplication. So minus 3 7s are minus 21 and 4 8s are 32. So I got the answer as minus 21 upon 32, which is a rational number. That means we got the answer as rational number only. But the one fact, that is, for any rational number a, if I divide a by 0, which will not get the answer as a rational number. It is not defined only. Okay. However, if we exclude 0, then the collection of all other rational number is closed under division. But just because of this one factor, that is when we divide any rational number by 0, it will not hold. That's why we can say that rational numbers are not closed under division. Okay. Now let's move to the second property, that is commutative property. Okay, let's check it for the addition. That is, commutative property for addition says that for any two rational numbers a and b, when we add a plus b, that also will give you the same answer as b plus a. Okay, that means a plus b is equal to b plus a. Let's check with the help of example. Here I am taking the value of a as minus 7 upon 9 and b as 5 upon 2. Okay, so here the a plus b is the LHS part and b plus a is the RHS part. Okay, so first of all we will solve LHS part, that is a plus b. So the first one, minus 7 upon 9 plus 5 upon 2. Okay, now we have to find the LCM of 9 and 2, but 9 and 2 are co-prime numbers. So directly we will multiply. So 9 2s are 18. Okay, and now we have to multiply this minus 7 by 2. So minus 7 into 2 is minus 14 and 9 5s are 45. Now minus 14 plus 45 will give you the answer as 31 upon 18 with plus sign, because 45 is greater number and which is having plus sign. Okay, so I got the LHS part as the answer 31 upon 18. Now let's check for RHS part. B plus A, that is 5 upon 2 plus of plus of minus 7 upon 9. Now here 2 and 9 are co-prime numbers, so 2 9s are 18 is the denominator, and here 5 9s are 45 plus in the bracket minus 14, because 2 7s are 14 with we have one number with the negative sign, so the number will become minus 14. Now 45 minus 14 is equal to 31 upon 18, which is equal to the LHS part. Therefore we can say LHS is equal to RHS. That's why addition is commutative for rational numbers. Okay. Now let's check this property for subtraction. See, a commutative property for subtraction. Subtraction is not commutative for integers, and integers are also rational numbers. So, the commutative property for subtractions does not hold for integers, and integers are also rational numbers. So, subtraction will not be commutative for rational numbers too. That means A minus B is not equal to B minus A. Let's check with the help of example. Here the value of A is minus 7 upon 9 and B is 5 upon 2. Okay, so first of all we will solve LHS part, that is A minus B. So minus 7 upon 9 minus 5 upon 2. Okay, now as 9 and 2 are co-prime numbers, so the denominator is 18. And now minus 7 multiplied by 2 gives us minus 14. In between we have negative sign now, and 9 5s are 45. Okay, now both the numbers are with same sign, therefore minus 14 minus 45 will give you the answer as minus 59 upon 18. Okay, now I got the LHS part is equal to minus 59 upon 18. Now let's solve RHS part. 5 upon 2 minus 7 upon 9. Now 2 9s are 18 is the denominator, and 5 9s are 45 minus in the bracket minus 14. Now 45 and that minus 14 will become plus 14, because outside the bracket we have negative sign. So 45 plus 14. Okay, now 45 plus 14 is equal to 59, but with positive sign, because here the bigger number is 45 which is having positive sign. Okay, now I got the answer same, but the signs are different. As because of signs are different, we can't say that LHS is equal to RHS. LHS is not equal to RHS. That's why subtraction is not commutative for rational numbers. Okay, now let's check for multiplication. Commutative property for multiplication. For any two rational numbers A and B, A into B is equal to B into A. Let's check for with the help of example. Here I am taking the value of A as 1 upon 3 and B as minus 2 upon 5. Okay. Now LHS part is A into B. So let's put the value of A and B. 1 upon 3 into minus 2 upon 5. Okay. Now as per the rule of fraction multiplication, we have to multiply numerator with numerator and denominator with denominator. That's why 1 into minus 2 is equal to minus 2 and 3 5s are 15. Okay. So I got the answer for LHS is minus 2 upon 15. Now let's check for RHS. First we have to write minus 2 upon 5 multiply by 1 upon 3. Okay. Now minus 2 1s are minus 2 and 5 3s are 15. So I got LHS is equal to RHS. That's why multiplication is commutative for rational numbers. Okay. Now let's check for division. Commutative property for division. Division is not commutative for integers, and integers are also rational numbers. So division will not be commutative for rational numbers too. That means A divided by B is not equal to B divided by A. Actually A divided by B is also will not give you the rational number only if when we have b as equal to 0. That we understood in the part of closure property, right? So actually commutative property will not hold for division. Let's check for the with the help of example once again. So here I am taking the value of a as 1 upon 3 and b as minus 2 upon 5. So we have to find out a divided by b first of all. So a is 1 upon 3 should get divided by minus 2 upon 5. As per the rule of fractions, we have to change the sign by multiplication and we have to find the reciprocal of the second number. So 1 upon 3 will remain as it is. And we will write here multiplication sign and then we have to write 5 upon minus 2. Okay, now we have to follow the rule of multiplication, that is 1 into 1 5 are 5 and 3 2s are 6 with negative sign. So I got the answer as 5 upon minus 6 as the LHS part. Now let's check for B RHS part. So B is here minus 2 upon 5 and should get divided by 1 upon 3. Okay, now as per the rule of multiplication, we have to keep the first number as it is and we have to write the multiplication sign and then reciprocal of the second number, that is 3 upon 1. So I got the answer as minus 2 3s are minus 6 upon 5 1s are 5. Actually I got the answer, the digits are same but the reciprocal of each other. That's why we can say that LHS is not equal to RHS. Therefore division is not commutative for rational numbers. Okay, now let's move to the next property, that is associative property. For addition we will check. Associative property for addition says that for any three rational numbers a, b and c, a plus in the bracket b plus c is equal to in the bracket a plus b, a bracket complete, outside plus c. Okay, let's check it with the help of example. Here I am taking the value of a as 2 upon 3 and b as minus 4 upon 5 and c as 6 upon 7. Okay, now LHS part is a plus in the bracket b plus c. First of all we will solve it. Okay, so the value of a, b, c I'll put in the formula. So 2 upon 3 plus in the bracket we have minus 4 upon 5 plus 6 upon 7. Okay, now as per the rule of BODMAS, first of all we have to solve the bracket. So I'll keep that 2 upon 3 as it is and in the bracket we have minus 4 upon 5 plus 6 upon 7, as 5 and 7 are co-prime numbers, so the denominator will be 5 7s are 35. Okay, and minus 4 into 7 we have to write, that is 28, and 6 5s are 30. Okay, now minus 28 plus 3 is how much? 2. So the 2 upon 3 will remain as it is and plus in the bracket we have 2 upon 35 with plus sign because 30 is bigger number and which is having plus sign. Now again we have denominator as 3 and 35 and both of them are also co-prime number. Therefore we will write 3 35s are 105. Okay, now in the first number we have 2 that we should multiply with 35. So 35 2s are 70 and here 3 2s are 6. So the final answer is 76 upon 105. Okay, this is the LHS part. Now let's solve the RHS part. In the bracket we have 2 upon 3 plus minus 4 upon 5 and outside bracket we have 6 upon 7. Okay, so first we will solve the bracket. So 2 upon 3 plus minus 4 upon 5. Now here 3 and 5 are co-prime numbers, so 3 5s are 15 we have in the place of denominator and we have to multiply this 2 with 5, so 2 5s are 10 plus in the bracket minus 4 into 3 is minus 12. Okay, and outside bracket we have plus 6 upon 7. Now 10 plus of minus 12 will give you the answer as minus 2. So the minus 2 upon 15 is there and outside we have 6 upon 7. Now again we have to find minus 2 upon 15 plus 6 upon 7. So here 15 and 7 also are co-prime number. So 15 7 sum 105, and now I have to multiply that minus 2 into 7 which is equal to minus 14, and 15 into 6 which is equal to 90. Now minus 14 plus 90 both are with different signs, so we have to subtract. 90 minus 14 is 76 with positive sign. So I got the same answer as LHS part. I got LHS is equal to RHS. That's why addition is associative for rational numbers. Okay. Now let's check for multiplication. Associative property for multiplication. You might have thinking that why I didn't check for subtraction, because commutative property does not hold for subtraction for rational numbers, right? That's why we can't say we can't find out for associative property. Okay, so directly I move to multiplication. Associative property for multiplication, which is saying that for any three rational numbers a, b, c, a into in the bracket b into c is equal to in the bracket a into b bracket complete into c. Okay, let's check it with the help of example. Here I am taking the value of a as 1 upon 2, b as minus 3 upon 4, and c as minus 5 upon 6. Okay. Now let's solve LHS part first. Okay, so the LHS part we have a into in the bracket b into c. Let's put the value of ABC in the formula. So it will become half into in the bracket minus 3 upon 4 into minus 5 upon 6. Okay, first of all we have to solve the bracket. So this half will remain as it is, and as per the rule of fractions we have to multiply numerator with numerator and denominator with denominator. So minus 3 into minus 5 will give you plus 15, and 4 6 are 24. Okay, now we have to multiply half into half into 15 upon 24. So 15 ones are 15 and 24 twos are 48. This is the value of LHS. Let's find out the simplest part of 15 upon 48. That is 3 5s are 15 and 3 16s are 48. So I got the final answer as 5 upon 16. Now let's solve the RHS part. Here we have in the bracket half into minus 3 upon 4, and outside bracket we have minus 5 upon 6. Now first we will solve the bracket. So 1 minus 3 are minus 3 and 2 4s are 8, and outside bracket we have minus 5 upon 6. Okay. Now let's multiply minus 3 into minus 5 which is equal to plus 15 upon 8 6 are 48. Same we got. Let's reduce it. So 3 5s are 15 and 3 6 are 3 16s are 48. So I got the final answer as 5 upon 16. That's why LHS is equal to RHS. That's why we can say that multiplication is associative for rational numbers. Okay. Now division also does not hold for commutative as well as for closure properties. So we can directly say that the division does not hold for associative property. Now let's move to the next property, that is identity property. Identity property for addition is 0. Okay, 0 is called the identity for the addition of rational numbers, because whenever we add 0 with any rational number, we will get the answer as that rational number only. Let's check with the help of example. Here I am taking the rational number minus 5 upon 3, and let's add it with the 0. See here, whenever we add any number with 0, we will get the answer as that only, because denominator will remain as it is first of all, and minus 5 plus 0 is minus 5 only. So we got the same answer as that rational number. That's why we can say that 0 is an additive identity for rational number. Okay. Now we have one more identity property, that is for multiplication, that is 1. 1 is called the identity for the multiplication of rational number, because whenever we multiply any rational number with 1, we will get that rational number only as the answer. I am taking here the example as minus 2 upon 7. Let's multiply it with the 1, and you all know that whenever we multiply any number with the any rational number with the whole number, just we have to keep the denominator as it is and the whole number multiplied with the numerator. So minus 2 ones are minus 2 and the 7 will remain as it is. That's why we can say that 1 is a multiplicative identity for rational numbers. Okay. Now we have one more property, that is distributive property. Here the first property of distributive is distributivity of multiplication over addition. For all rational numbers a, b and c, we can say that a into in the bracket b plus c is equal to a into b plus a into c. Let's check with the help of example. Here I am taking the value of a as 2 upon 3, b as minus 1 upon 3 and c as minus 2 upon 5. Okay. Now let's find first of all LHS part. So 2 upon 3 multiplied by, in the bracket we have minus 1 upon 3 plus minus 2 upon 5. So first of all we will solve the bracket. So 2 upon 3 will remain as it is. Okay, and now here 3 and 5 are co-prime numbers. So 3 5s are 15 will come in the denominator. And now we have to multiply that minus 1 into 5. So minus 1 5s are minus 5 and minus 2 3s are minus 6. So now minus 5 plus minus 6 will give you the answer as minus 11 upon 15, and that we have 2 upon 3 outside. Okay, so now we have to multiply 2 into minus 11, which is equal to minus 22, and 3 15s are 45. This is the answer of LHS. Now let's check for RHS. We have a into b, so 2 upon 3 into minus 1 upon 3 plus then a into c, that means 2 upon 3 into minus 2 upon 5. Okay. Now first bracket will give you the answer as 2 minus 1s are minus 2 upon 3 3s are 9. Then plus second bracket will give you the answer as 2 into minus 2 is minus 4 and 3 5s are 15. Now we have in between plus sign, so we have to find the LCM of 9 and 15. Okay. So 3 3s are 9, 3 5s are 15. Now 3 1s are 3, 5 will remain as it is. Now 5 1s are 5. So I got the LCM as 45. 3 into 3 into 5 gives us the answer as 45. Okay. So we have to write 45 in the place of denominator, and now we have to check 9 what's are 45, 9 5s are 45. That's why we have to multiply the numerator with the 5. That means minus 2 into 5 will come, then plus sign will come. Then we have to check 15 what's are 45, 15 3s are 45. That's why we have to multiply this minus 4 with 3. So plus in the bracket minus 4 into 3. Now we have minus 2 5s are minus 10 and minus 4 3s are minus 12. Now minus 10 plus minus 12 is equal to minus 22 upon 45, which is equal to LHS part. That's why we can say that LHS is equal to RHS. That's why distributivity of multiplication over addition for rational numbers holds true. Right? Now let's check distributive property for subtraction. Okay, that is distributivity of multiplication over subtraction. That is same, only just in terms of plus sign we have to use here subtraction. Let's check it with the help of example. Here I am taking the value of a as minus 1 upon 5, b as minus 2 upon 3 and c as 1 upon 4. Let's solve LHS part first of all. Okay. So a is here minus 1 upon 5, and now we have multiplication sign, and in the bracket we have minus 2 upon 3 minus 1 upon 4. First we have to solve the bracket, and 3 and 4 here are co-prime numbers. So we have to directly multiply. Minus 1 upon 5 will remain as it is, and 3 4s are 12. Okay, and now minus 2 will get multiplied with 4. So I got here answer minus 8, and now we have minus and in the bracket 3. 1 3s are 3. So now minus 8 minus 3 will give you the answer as minus 11 upon 12. Okay, now we have to multiply this minus 11 upon 12 with minus 1 upon 5. So minus 11 into minus 1 will give you plus 11 and 5 12s are 60. This is the answer of LHS part. Now let's solve RHS part. A is here minus 1 upon 5 into minus 2 upon 3 minus in the bracket minus 1 upon 5 into 1 upon 4. Okay. Now minus 1 into minus 2 is equal to 2 plus 2 upon 5 3s are 15 minus in the bracket minus 1 1s are minus 1 and 5 4s are 20. Now we have to find the subtraction, and here 15 and 20 are not co-prime numbers, so we have to find the LCM of 15 and 20. So here 5 3s are 15 and 5 4s are 20. Now 3 1s are 3, 4 will remain as it is, 4 1s are 4. So I got the LCM as 60. Okay. Now the denominator will become 60, and now we have to check 15 watts are 60, 15 fours are 60. So we have to multiply this 2 with 4, and then we have to check 20 watts are 60, 23s are 60. So we have to multiply this minus 1 with 3. Okay, so now I got 2 fours are 8 and minus 1 3s are minus 3. So as outside the bracket we have minus sign, so we have to change the sign of minus 3. That will become plus 3. That's why the answer will be 11 upon 60, which is equal to RHS. That's why we can say that distributivity of multiplication over subtraction for rational numbers also holds true. So here I explain all the properties, and here I have summarized all the properties. You can go through it. If you have any doubt, you can ask me in the comment box. If you like my teaching, then please subscribe to my channel. Bye everyone.